Hello everyone, welcome to this video on the qualitative tests that can be used for the detection of elements belonging to the first transition series. The D block elements, or as we call them, the transition elements, have this unique property of being able to form colored compounds. This property is helpful in the detection of these metal ions in the laboratory. In this video, I'm going to talk about some of the common tests that are used for the detection of elements belonging to the first transition series in the laboratory. So let's start. Let's start with the metal chromium. The first test that I'm going to talk about is the borax bead test. If a compound of chromium is fused with borax and the resultant bead, the resultant fused mixture is heated in an oxidizing flame, a green colored borax bead is obtained. The appearance or the formation of a green colored borax bead is an indication of the presence of chromium in the given compound. The second test, that is the addition of liquor ammonia to a chromium solution, that is to a chromium aqueous solution, will result in the formation of a grayish blue precipitate that is due to the formation of chromium hydroxide. However, this precipitate will dissolve on the addition of excess ammonia. Ammonia here is acting as a coordinating group, and addition of the excess coordinating group is dissolving the grayish blue precipitate, and we are having the formation of a pink colored solution that is due to the formation of the hexaamine chromium complex, chromium being in the +3 oxidation state here. Another test that can be used for the detection of chromium is when a chromium salt solution in a slightly acidic medium is treated with lead acetate, a yellow precipitate is obtained. The yellow precipitate is due to the formation of lead chromate. Let's talk about the second metal, manganese. Manganese, if borax bead test is performed with a manganese salt, an amethyst colored borax bead is obtained. Manganese salts in the +2 oxidation state, if they are treated with sodium bismuthate in the presence of nitric acid, the solution will turn purple, that is due to the formation of manganic acid, where manganese is there in the +7 oxidation state. A similar observation is obtained when aqueous manganese salt solutions are treated with lead dioxide and nitric acid. A purple color solution is obtained due to the formation or due to the oxidation of manganese from +2 to the +7 oxidation state. The next metal, iron. Ferric salts, when they are treated with aqueous ammonium thiocyanate, a red coloration is obtained due to the formation of the thiocyanato complex of Fe in the +3 oxidation state. Similarly, when a ferric salt solution is treated with potassium ferrocyanide K4FeCN6, we get a Prussian blue coloration. This is due to the formation of the complex iron potassium hexacyanoferrate. A ferrous salt solution on treatment with K3FeCN6 also gives a Prussian blue coloration due to the formation of iron potassium hexacyanoferrate. Cobalt, the next metal, it gives a deep blue colored bead if the borax bead test is performed for a cobalt salt. On treatment with ammonium thiocyanate, an aqueous solution of cobalt, where cobalt is there in the +2 oxidation state, will give a blue colored complex. This is due to the formation of diammonium tetrathiocyanato complex of cobalt. A reddish brown colored precipitate is obtained for a cobalt salt with alpha nitroso beta naphthol. Nickel gives a brown colored bead with the borax bead test, a very famous test that we all have come across many times in the laboratory. A solution of nickel, where nickel is there in the +2 oxidation state. If it is treated with an ammoniacal solution of dimethyl glyoxime, we get a scarlet red precipitate of bis dimethyl glyoxymeto complex of nickel. Another test which we can consider for the detection of nickel is nickel salt solutions. They give a mauve colored precipitate on treatment with ethylene diamine and sodium thiosulfate. Here the complex formed is tris-ethylene diamine complex of nickel, nickel being in the +2 oxidation state. Copper gives a characteristic blue colored flame in the flame test and a blue colored bead in the borax bead test. If a copper +2 aqueous solution is treated with liquor ammonia, initially a bluish white precipitate of copper hydroxide is obtained. This precipitate will dissolve on the addition of excess liquor ammonia. Ammonia group will be acting as a coordinating group over here and a blue colored precipitate is obtained. It's not a blue colored precipitate, a deep blue colored solution is obtained, which is due to the formation of the tetraamine complex of copper. Understand here, the bluish white precipitate of copper hydroxide is dissolving due to the formation of a soluble complex, that is the tetramine complex of copper. Copper salt solutions also form a chocolate colored precipitate with K4FeCN6, that is due to the formation of copper hexacyanoferrate complex. So these were the metal ions that we have considered of the first transition series and the tests that can be used for their detection in the laboratory. Thank you for watching this video. See you soon. Bye-bye.